What's up, folks? How's it going? This is Avijit here, and welcome to DevOps Challenge Hub. So let's start with today's interview question. Today's interview question is: Your application has successfully passed SonarQube SAST scans and has been deployed to a staging environment. And before you promote it to the production, how would you test running application for security vulnerabilities, and what role does DAST play in this process? So we'll look at what is a SAST versus DAST, where we do DAST, where SAST can't capture those issues. Okay. So what is SAST and DAST? Like SAST is, it's the most commonly stands for static application security testing, and DAST is dynamic application security testing. So SAST means you just look into the source code binaries. You don't need the running application. Look into the code, see what kind of vulnerabilities are there. Maybe someone hard coded the API key, etc., or the bad way coding was done. It's a bad code basically. SAST detects the bad code, and DAST detects bad behavior of the application. Application should be running, right? DAST application should be running. It detects the bad behavior. SAST detects bad code. Okay. So why it's needed? Why DAST is needed? Because some vulnerabilities only appear when the application is running. By just looking at the code, you can't figure it out. And how it works? You run the application, then DAST tool will send some request. Then test the URL. It will try to submit the form. It will try to send some junk data, like malicious data, right? And it will try to identify the vulnerabilities. Right? For example, a website this myapp.com login, Dust tool will submit some malicious inputs and discover that there is a cross-site scripting issue or SQL injection issue is there. So common tools are OWASP, ZAP, Barsuit, Aconetics, and Invicti. These are some of the tools which are used for dynamic application testing. So what are the benefits? The benefits is detect runtime vulnerabilities that may not be visible in the source code. By looking at the source code during static analysis, you won't be able to find out. So how it's done? So developer commits, build happens, then static application security testing happens using SonarQube. We'll look into the source code, etc., and find out what are the bad code is there. Right? And then once that is done, Docker build happens. After that, you deploy to the staging environment. Application is running. Now you use the DAST and that is dynamic application security testing. For example, you can use this tool OWASP ZAP and see what are the issues are there. Like maybe some port is open, which should not be open. That you can find out during uh, dynamic testing when the application is running. Right? So without DAST, vulnerabilities may only be discovered after the deployment. Runtime security issues can be missed. So what are the some common vulnerabilities detected by DAST? SQL injection, cross-site scripting, broken authentication, security misconfigurations, right? Maybe directory listing is enabled. So you are able to see all the directories of the web folder. Debug mode is enabled. So these are the misconfiguration. Debug mode developer has enabled to see more details, but it should not be enabled in the production. So some common tools we have discussed: OWASP ZAP. It's the most common open source DAST tool. Then we have Barsuit, popular penetration testing tool. Aconetics, enterprise web scanning. Invicti, automated web security testing. So these are some of the common difference, like static application security testing versus dynamic application security testing. In static application security testing, you need the source code, but here you don't need. Application running, no. Here you need application to run. Testing stage, it's during development build phase, you run this application, run this tool to find out static code-related issues. Here, the staging test environment side detects code level vulnerabilities. Here, DAST tool detects runtime vulnerability. Code level, and this is runtime. Tool used SonarQube, here you use OWASP ZAP. Some common vulnerabilities that DAST can detect: SAST often misses session management issue, weak session ID, session fixation, right? Business logic flaws. By looking at the code, it's very difficult to find out. Cross-site scripting and business logic won't be able to understand SonarQube. Server misconfiguration, security header issue, TLS is SSL configuration, sensitive data exposure, API authorization issues. So all these kind of issues we will be able to find out during dynamic application security testing. So SAST is a bad code and DAST is a bad behavior. Bad behavior you identify. SAST is SQL injection pattern, hard-coded secret, weak crypto usage, unsafe API. DAST is basically login bypass, session flaws, misconfiguration, business logic abuse. They're the things you will be able to identify using DAST. So that's it for today. Hope you like this video. Please like, share, and subscribe. And please share with your friends. And see you again in the next.